Hello class, today we are taking a look at our multiplying and dividing fractions readiness guide. First thing we need to be able to do is use both our symbolic rules and our models to be able to multiply fractions, mixed numbers, and whole numbers, and any sort of combination thereof. So if we take a look at our first question, we got 5 times 2/3. In terms of our symbolic rules, we want to follow our process of rewrite, top by top, bottom by bottom, and simplify at the end. We always simplify our fractions. So if I take a look at question A, I want to start by rewriting that whole number as a fraction. So any whole number can be written as a fraction by dividing it by 1. And from here, there's nothing really else I can do. So I'm going to go ahead and multiply top by top. So 5 times 2, bottom times bottom, 1 times 3. And then let's do those calculations. 5 times 2 is 10 on the top, 1 times 3 is 3 on the bottom. So 10/3 is going to be our answer. Now, if it was just a symbolic question, 10/3 would be completely appropriate as an improper fraction. Let's also convert that to a mixed number. 3 goes into 10 3 full times. Now, 3 times 3 would be 9, so it would be 1 left over in our 10 there. So that would be 3 1/3 as a mixed number. Now, if I want to draw a model for this one, I need to have 5 groups and 2/3 in each group. So let's go ahead and set up 5 circles for our groups. 1, 2, 3, 4, 5 groups. In each group, I need 2/3. So I'm going to need 1 whole in each group. I need to divide those wholes into thirds, or 3 parts each. So 2 dividing lines make 3 parts. And I actually have 2 parts in each of those. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. If I count up how many thirds I have in total, well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thirds in total. So again, in total, there are 10 thirds, which is the same answer we got from our symbolic work. 1/4 times 3. So I need to go ahead and again rewrite that 3 as 3 over 1. Then I can multiply top by top, 1 times 3, and bottom times bottom. 1 times 3 is 3, 4 times 1 is 4. So 3/4 is going to be my answer as a fraction. Now, if I want to go ahead and do that, I want to start by modeling 1/4. And then I have 1/4 of 3 groups. So again, I've got 3 groups of 1/4. So there's my quarters, and I've got 1 each of those. Obviously, in total, I have 3/4. Or 3/4 if you prefer. Last one here, I've got 2/3 times 5/6. So I want to go ahead and multiply top by top, bottom by bottom. It's going to give me 10 over 18. I do notice that both of those are even, so I can simplify them. I'll divide them by 2. And that gives me my simplest form answer of 5/9. If I want to model this, what I need to do is represent 1 whole. And I'm going to represent one of these as the columns. So I'll do 2 out of 3 columns. There's my 2 out of 3 columns. And then my other fraction, will be rows. So I'll have 5 out of 6 rows. 1, 2, 3, 4, 5, 6. And I've got 5 out of 6 of those. And remember, my solution is where I have both. So if I count this up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections. And we want to count up the number of parts in our whole. We've got a 3 by 6 grid here, so there's 18 parts in the whole. And of course, 10 out of 18 simplifies to 5 over 9 as well. In terms of division, we want to remember that the first number is always what we're starting with, and then we're splitting it up either into groups of the second number, if the second number is a fraction, or into blank groups, if the second number is a whole number. For our symbolic rules, we of course want to rewrite. Then we're going to multiply by the reciprocal. And so that looks like leave the first fraction. We are going to change divide to multiply. And we're going to flip the second fraction. So we're going to rewrite in question A by writing our whole number over 1. Then we are going to multiply by the reciprocal, so we'll keep that first fraction, change divide to multiply, change second fraction to its reciprocal. 4 times 3 on top is 12, 1 times 2 on the bottom is 2. 12 divided by 2 is the whole number 6. Now, if I want to go ahead and draw my model here, I need to start with 4 whole objects. There's 4 whole objects, and I do have all of them. And then I need to split that into groups of 2/3 at a time. So I'll make these whole objects into thirds. And anytime I can circle 2 of those sections at a time, that'll be one group. So here's group 1, group 2, group 3, group 4, group 5, group 6. We make 6 groups, and that's why our quotient is 6. In the case of question B, we are again going to rewrite by writing our whole over 1. Then we'll flip and multiply, so keep our first fraction, change divide to multiply, flip second fraction. 5 times 1 on the top is 5, 6 times 3 on the bottom is 18, and that's about all we can do. For our model, we need to start by drawing 5 sixths. So I'll go ahead and do that. Need to draw 6 sections. 1, 2, 3, 4, 5 dividing lines make 6 sections. And then I actually have 5 of those. Now I need to split those into 3 equal groups. I can't take 5 objects and put them into 3 equal groups, but I can cut them into 3 equal sections, so that's what I'll do. And then one of those sections will be the value of my answer. So in here, this is group 1, group 2 here, and group 3 here. And we can say in each group, there are 5 parts. And in this whole now, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 parts. So that's why we have our 5 out of 18, same as from our symbolic work. Finish up here, our symbolic work's pretty easy for this question. I'll just actually write it underneath here. So we're going to keep our first fraction. We're going to change divide to multiply. We're going to flip our second fraction. And we are going to multiply those. 2 times 5 is 10 on top. 3 times 4 is 12 on the bottom. Simplify. Gives us 5 over 6 as our answer. Get our equal signs in here. For our model, we need to start by drawing our 2/3. There's 2/3 of our whole. Now we need to reorganize that into groups of 4 out of 5 rows at a time. So let's start by making 5 rows. 1, 2, 3, 4 dividing lines makes 5 rows. And then we need to rearrange these into the rows instead of the columns. So I'll go ahead and make the same number of rows and columns. Like that. But I need to take the parts that I have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And anytime that I've filled up 4 full rows, that would be one group. So this would be one group, but it's actually only a partial group. And in that partial group, I have 10 out of the 12 parts. For a full group. And so, of course, that's the same fraction, 10 out of 12, that we got over here. Okay, taking a look on the back side, we're dealing more with just calculation questions. In these calculation questions, again, you want to be watching out for your tricks, your rewriting especially. So if I take a look at something like question A, I want to start by simplifying my fractions. I notice that both 12 and 24 are multiples of 12, so I can divide there to get 1/2 as a simpler fraction. And both 35 and 49 happen to be multiples of 7, so I can divide there as well to simplify that fraction. And obviously this is now a much easier question to complete, especially since we don't really have to simplify anything at the end after multiplying. So 1 times 5 on the top is 5, 2 times 7 on the bottom is 14. 5 out of 14 is our answer. You know, you don't want to be messing around on your exam with doing this nonsense, because that's going to take you a while, and then you'll have to simplify it at the end. It's much easier to simplify at the start, and that's one of our main tricks here. Now, we can also work to cancel across fractions as long as we have factors. Factors are multiplied, so we need to be at the multiplying stage of the question first. If we take a look at something like question B, we are not multiplying between the fractions yet, and I can't simplify either fraction as it is. So I'm going to go ahead and flip and multiply here. So I'm going to go 9 over 16 times instead of divide, and 9 over 8 is my second fraction there. Now when I do this, I've got 9 times 9 on top, which is 81, and 16 times 8. I don't know what that is, but let's go ahead and work it out. 8 times 6 is 48. 8 times 1 plus 4 is 12. 128 on the bottom. I happen to know that this won't simplify, because if I think about my factors of 16, they're 1, 2, 4, and 8. The only factors of 9 are 3. And so obviously, 1, 2, 4, and 8 are not 3. Nothing will divide there. Okay. Take a look at something like question C. Oops, that's the same one. I wanted this one to be multiplying. I was thinking that. Is unfortunate. Let's actually do that one as multiplying. Little typo there. Now this is one where we can cancel a factor of 9 across our fractions. So we've got a factor on the top, a factor on the bottom. They can in fact cancel there. We end up with our 8 out of 16. Now you might notice that 8 out of 16 simplifies here, and in fact we could have simplified that at the start as well. Both the 8 on top and the 16 on the bottom can divide by 8. Now that's going to give us the simpler fraction 1 out of 2 times 1 out of 1. And 1 out of 1 gives us that. Okay, multiplying by 1 doesn't change that first fraction. Now likewise, like we just did, I'll just put this in for our post-it copy. We're going to flip and multiply. And then we've got 81 on top and 128 on the bottom, which does not simplify. Box in those answers. Okay, taking a look at question D. Nothing simplifies in the first fraction. 16's factors are 2, 4, and 8. and then 21 is 3 and 7. So nothing simplifies there. Same in the second fraction. So I'm going to move on to flipping and multiplying and see what happens then. And now I do see some simplifications I can do. So both 16 and 8 can divide by 8 there. So that's already a good simplification to start with. But also you may notice that both 21 and 35 are multiples of 7. So let's divide those by 7 as well to simplify. 16 divided by 8 on top is 2, 3 on the bottom, times 35 divided by 7 is 5, and then 1 on the bottom. 2 times 5 is 10, and then 3 times 1 on the bottom is 3. So much easier to simplify there prior to doing your multiplication. Last one here, just a reminder that when we are working with mixed numbers, we need to convert those to improper. We do that by multiplying our whole number by the bottom and then adding in the top. So 2 times 4 is 8, plus 1 is 9. And then 1 times 6 is 6, plus 5 is 11. Now we can go ahead and follow our normal dividing steps, which are flip and multiplying. So leave our first fraction, change divide to multiply, and then flip that second fraction. I'm going to go ahead and choose to simplify here, although I definitely don't have to. That'll give me 9 over 2 times my 3 over 11. 9 times 3 is 27, 2 times 11 is 22, and that's going to be my simplest answer there. Okay, in word problems, we want to fill in information to other parts of the question and look for connecting words that either mean multiply or divide. So in question A, we've got there was 5/8 of a pie left over. Daniel ate 3/4 of the leftover pie. Well, we're going to go ahead and cross out our leftover pie and fill in what we know about that. That leftover pie is 5/8 of a pie. So we want to find 3/4 of 5/8. And of course, is a word that means multiply. So this is 3/4 times 5 over 8. 3 times 5 is 15, 4 times 8 is 32. So we can conclude that Daniel ate 15 32nds of a whole pie. Single cup of flour weighs 2/9 of a pound. How much does 2 2/3 cups of flour weigh? So we have 2 2/3 groups. Of each group is 2/9 of a pound. And again, this is going to be a multiplying question because of that of. So let's convert our mixed number to improper. 2 times 3 is 6, plus 2 is 8/3, times our 2/9. 8 times 2 is 16, 3 times 9 is 27. So we're going to say that overall this weighs 16/27 of a pound. Now, if we just kind of check ourselves on that a little bit, we know, of course, that 1 pound is 2/9. That means 2 pounds is 4/9. And then a little bit of extra there would get us close to multiplying by 3 more than 12 out of 27. So 16 out of 27 makes sense there. Buffet prepares 5 7/8 pounds of turkey for dinner. If each patron takes 1/3 of a pound of turkey, how many patrons can be fed? So what we're doing is we're starting with our 5 7/8 pounds, and we're splitting it up for dinner, or cutting it up for dinner, and we're cutting it into groups of 1/3 at a time. So we have 5 7/8. We want to divide that by 1/3. We're going to convert that mix to improper to calculate here. 5 times 8 is 40, plus 7 is 47/8. And we need to divide that by 1/3. We're going to flip and multiply 47/8 times 3 over 1. And let's do that calculation. 47 times 3, well, that's a good one. 3 times 7 is 21. 3 times 4 plus 2 is 14. So we have 141 eats worth of servings. Now we want to know what that is in terms of people, keeping in mind that we probably don't want to serve anyone a partial serving. So I'm going to go ahead and divide 141 by 8. 8 goes into 1, 8 goes into 14, 6. 8 goes into 61 7 times, making 56. And that's going to leave us with 5. So we can say that this is 17 and 5/8. And so we can say 17 full people can receive a full 1/3 serving. Okay, so this is a good case where we have some context that implies that you probably shouldn't have the partial part. Our calculation here has an answer of 17 and 5/8. Despite that, we're going to round down just to represent the fact that, we're not going to give someone less than 1/3 of a pound of meat for their dinner. Okay. Now, in that case, if you explain what's going on, you're probably getting full marks either way, but just make sure you have an explanation for why you are or are not giving that exact answer. Last one, how many batches of cookies can you make with 8 cups of flour if each batch requires 2/5 of a cup? So we have 8 cups of flour and we want to split into groups of 2/5 again. So again, we're going to divide there. We're going to rewrite our 8 as 8 over 1. And then we'll flip and multiply. So 8 over 1 stays the same as our first fraction. Change divide to multiply. 5 over 2 now is our reciprocal. 8 times 5 is 40. 1 times 2 is 2. 40 divided by 2 is 20. And you can make 20 batches. So I hope that's helped with your multiplication and division of fractions. Readiness guide.